This is lesson 29 on gray code converters. What's a gray code? Well, gray code is an ordering of 2 to the n binary numbers such that only one bit changes from one entry to the next. So for example, here's the familiar binary coding 0, 1, 2, 3, 4, 5, 6, 7. But you notice, for example, in going from 1 to 2, both of these rightmost bits change. This goes from a 0 to a 1 and from 1 to a 0. But in gray coding, we only want to change one bit. So 0, 1's okay, but now only this second bit changes. So it looks like a 3, even though this would be a gray code for 2. And going here, only the last bit changes. Then going from here to here, this leftmost bit changes. Going from here to here, the 0 becomes a 1. Here to here, this 1 becomes a 0. Here to here, this 1 becomes a 0. So that's what a gray code is. Now, gray codes aren't unique, but one method of generating this sequence is to start with all bits 0 and then successively flip the rightmost bit that produces a new string. So you see, going from here to here, we can change 0 to 1. Now we've got to go to the next bit, because changing this back to 0 would give you what you had before. So now we change the second bit, but now we can change the first bit again because we get a new sequence. But now, to get a new sequence, we have to change this third bit to a 1. But once we do that, we can get back to the least significant bit and change this 0 to a 1. Then we need to change the second bit to a 0, and now we can go back to the first bit to become a 1. So that's one way of doing it. There's also an algorithm for converting any binary sequence to a corresponding gray code. And this is the algorithm. You copy the most significant bit, so the zeros become 0 here. And then for each smaller bit, these next two, the next GI, this one, is just the BI plus 1, that is this most significant bit, exclusive order with the next one. So 0 exclusive order with 0 is 0, 0 XOR 0 is 0. Here you copy the first bit, 0 exclusive order with 0 is 0, 0 exclusive order with 1 is 1. Copy the most significant bit, 0 XOR 1 is 1, 1 XOR 0 is 1. Copy the first bit, 0 XOR 1 is 1, 1 XOR 1 is 0. Copy the most significant one, 1 XOR 0 is 1, 0 XOR 0 is 0. Copy the 1 here, 1 XOR 0 is 1, 0 XOR 1 is 1. Copy the most significant one, 1 XOR 1 is 0, 1 XOR 0 is 1. Copy the most significant, 1 XOR 1 is 0, 1 XOR 1 is 0. So that's how it works. This shows a 4-bit binary coding and the corresponding 4-bit gray coding. This algorithm is the 4-bit version of our binary to gray coding algorithm. G3 gets B3, most significant bit gets copied. Then for I equals 2, I greater than or equals 0, I equals I minus 1. GI is BI plus 1 exclusive order with BI. So this algorithm produces this circuit, that is G3 gets B3, then for I equals 2, G2 is just B3 exclusive order with B2, G1 is just B2 exclusive order with B1, and G0 is just B1 exclusive order with B0. So this simple circuit will implement this binary to gray code conversion for 4 bits. Now let's look at going the other way around, gray code to binary conversion. Here's the gray coding we had before, and we want to go to this corresponding binary numbers. It's a little different than we had before. We still copy the most significant bit, but then for each smaller I, BI is BI plus 1 exclusive order with GI. So now this is the BI plus 1, so here we copy the first one, but to get the second one we need to take the exclusive OR of this B3 in this case with this G. So 0 exclusive OR with 0 is 0, 0 exclusive OR with 0 is 0. Copy the 0, 0 exclusive OR with 0 is 0, 0 exclusive OR with 1 is 1. Copy the 0, 0 exclusive OR with 1 is 1, 1 exclusive OR with 1 is 0. Copy the 0, this is 0 exclusive OR with 1 is 1, 1 exclusive OR with 0 is 1. Copy the 1, 1 exclusive OR with 1 is 0, 0 exclusive OR with 0 is 0. Copy the 1, 1 exclusive OR with 1 is 0, 0 exclusive OR with 1 is 1. Copy the 1, 1 exclusive OR with 0 is 1, 1 exclusive OR with 1 is 0. Copy the 1, 1 exclusive OR with 0 is 1, 1 exclusive OR with 0 is 1. So that's how it goes. Here we have a 4-bit gray coding and the corresponding 4-bit binary coding. This is our little pseudo code for converting 4-bit gray to binary. B3 gets G3, and then for I equal 2, I greater than or equals 0, I equals I minus 1. BI is BI plus 1 exclusive OR with GI. Now notice how this is a little different than the binary to gray code. Here the most significant bit gets copied, B3 gets G3, but now B2 gets B3 exclusive OR with G2, B1 gets B2 exclusive OR with G1, and B0 gets B1 exclusive OR with G0. So here, one of the inputs to these exclusive OR gates is a previous result. So this circuit involving these 3 exclusive OR gates will produce a gray code to binary conversion.